Assalamu alaikum warahmatullahi wabarakatuh. In this part of the tutorial video, the third part, we will discuss how to generate the support saddles and how to add lifting lugs on this bonnet head and another lifting lugs for this body flange, and how to make some modifications like on the flange hooling, like that on the tube sheet. We have some holes with some different details for the hauling, and how to make a chamfer on this flange. So we will discuss some of those points during this part, inshallah. Now let's start by creating the fixed saddle. So from here, let's select can tool, and from elements, let's add fixed saddle. And from the fixed saddle, we will select the type of the saddle web plate case to be the web at the right side. So let's define the contact angle. So from the saddle detail drawing, the contact angle is 120, and the web thickness is 12 millimeters, and the height is 750. 12 millimeters, and here we have a contact angle, and here's the width, and here's the thickness is 12, and here's the the fillet weld. Okay, here's the fillet weld is 50, and now the base plate is 730 by 100 millimeters with thickness 14. And for the hole diameter, let's check the drawing. It's 2 holes with 28 millimeters, okay, and with offset 50, and on the other side the whole offset is should be, I think the value is not correct. The hole here, hole spacing is, I think it's 100 millimeter, not 50, so the scale of this view is not correct. Okay, so let's come back here and define the whole diameter like that, and from the offset from the shorter edge is 100, and the offset from the long edge is 65. Okay, and the location, let's check the location. So the location is from the center of the base plate to the that edge is 747, and the orientation will be like that. And the wear plate offset, if we take a look to the saddle detail, so the wear plate offset is 25. Okay, and for the sides, it's straight sides. So if we take a look to this image here, the sides here with 90 degrees. So if we measure the angle from here to there, it's 90 degrees. So the sides is straight sides. So we will keep this checkbox selected. And for the web offset, it's at 0. And for the outer ribs, we have ribs 100 millimeter and 100 millimeter. And for the thickness, it's 14 millimeters. And we have intermediate ribs. And the spacing here as per this drawing is 150, and the thickness of this one, so it's 213 plus 14, it's 244, so 244. And now let's click on save. Okay, and now let's add another saddle. So we can take we will need to add another saddle with a left side, so it's a sliding saddle. Okay, it will not be right, it will be a left web. So we will select the second one here and define the projection, the thickness, and for the wear plate it will be like that, 730, it's 100, and base plate 14, and the long radius will be like that, and the slot length. So let's check the slot length. Here, as you can see, the slot is along to the end, so we will need to make that cut manual. So the half of slot is 7.5, so the slot length is 15. So this slot will be 15 millimeters. And from here, the location, we can measure it from this drawing. So let's come back here and measure the location from this point to the center here. It's 896, so it's 896. Here's the orientation, and it's 25. And for the width offset, it's 0. And here's the top width of the saddle. Top width of the saddle is 100 at the top and the bottom, so it will be 100, and the thickness is 14. And from here we have intermediate with the spacing as we did on the previous saddle, 244. One more thing, if you would like to make a rendering for elements during creation, you'll open the setting tab and make a render review for the childs and click save. And now when you click on run, simply the saddle assembly will be generated like that. Now we did both of the left and right saddle assembled to the vessel like that. Okay, now let's make a modification on the base plate here. So let's open this sliding saddle, and inside the base plate let's make a modification on that one and make a cut. So from here, or we can open this part separately, so we can make the modification easily here. And from here we can project the hole like that, and we could make a cut like that, convert this line to be a construction line. The same thing, we can do it on the other side and make this point connected to here, convert this line to a construction line, and all those lines equal, and give them a round value, let's say 100, and make an extrude cut. Okay, so let's select extrude cut through all and in both sides, and now we have this cut on this base plate. So the cut will be like that. Let's open the sketch and hide this sketch here. Let's delete this sketch and click save. Now we have the modification on this saddle by that way. Now we discuss that we will make some modification on those flanges and the tube sheet, but before that let's add a lifting lug here on this bonnet. So here we have a lifting lug here. So when you select the top head, and from elements you will find here different types of lifting lugs. So we can try lifting lug type 2. Okay, and if we select this type, you can figure that you can add it on an ellipsoidal head. So based on the image here on the bottom, that's in case if you have a shell, and that's in case if you have a head. Now let's define the dimensions. So the distance C, so we will need to go here, and it's 125, so it's 125, and offset D, which is the whole offset, it's 125, but I think it's not to scale. I think it's not to scale, but let's draw it 125, and the thickness of this lifting lug, it's 12 millimeters, and the hole is 30 and radius 35, so it's 12, and the F is 35 and hole diameter is 30. Okay, and the offset. Okay, so the offset is 260, and the orientation at 0 degree, and we have only one wear plate or no cooler plate. So let's run the assembly. So here we have this lifting lug on the this head. Now let's add a lifting lug to the body flange F1. So let's select F1 from here, and from elements, let's add a lifting lug. So from here, let's add lug A. Okay, and from here, let's define the bottom width 125, the thickness is 12, and the bin hole diameter is 30, and the radius is 35. Hole offset L is 125. The location will be on the mid of this one, so we can measure the distance from here to there. It's 85, so it's 85, and the orientation 45 degrees. No more data, so we can take a copy from this, okay, and make paste, okay, and name it as lug B. Okay, so it will be lug B, and rename, and from here the orientation we can make it 315, and run the assembly to start generating the lifting lugs on the body flange. Okay, now we have the lifting lug here on the body flange with the same dimensions. Okay, now let's check how to, as we discuss during that, how I would like to remember. Okay, with the modification on the flanges. Here we have some flanges here, and we would like to make a modification like adding a chamfer or adding some details for holing here. Okay, so if you would like to make a modification, for example, on this flange, you will just open this flange, and here for the facing you can make a chamfer at this end, and here let's check the chamfer value. It's 6 millimeters. So from here we can make this chamfer with 6 millimeters, and click save. From here close this one, and the same thing we can do it here, and adding a chamfer at this edge with 6 millimeters. Okay, and now let's modify the sum of holes here. So let's open, as you can see here, we add the chamfer at the end of the flanges. Now let's open this tube sheet, and for example, let's select some of those holes to make some modifications. So we can create a sketch here, and let's select some of those holes, like that one, for example, that one, and that one, for example. And now let's make an offset for this hole, like that, and let's select the yellow holes and make them construction only, and select the black holes and make them black circles, give them equal order, and give them the same diameter. And now you can make extrude for that with extrude cut. Okay, extrude cut. So we can make extrude cut and give that extrude a value for that, so we can check the value of this cut. It's not mentioned here, so we can assume it, let's say 15 millimeters. So it's extrude cut with value with 15 millimeters, for example, to be, or make it less. Let's make it 25. Okay. So as you can see here, we make some of those holes with some different definition. Okay, and now we have the 3D model of the this heat exchanger. As mentioned on the previous tutorial video for the vertical vessel, you can add some attachments like grounding lugs here, or a nameplate, or anything else. And you can add stiffening grips. Let's check some of that. Here for this nozzle, for example, that nozzle, we would like to add a stiffening grip. So from here, let's select CAN 4. Okay, and from elements, let's add nozzle support rib. So it will be A03 support rib. Okay, and actually we will need to give it the same location and same orientation. So when we move to this one, you will need to select the suitable configuration for your shape. Okay, so that's the configurations that we would like to do, and here the outside diameter of the pipe, and here the rib width and the rib thickness. And let's give it the same location, the same orientation, and let's measure the angle of this one. It's 23, so the angle is 23. And for the thickness, let's assume it as 10 millimeters. And for the rib width, so we can measure the width from here. So it's like this, it's 30 millimeters. So the width is 30, and from here the location, orientation, and the rib offset. As you can see, it's the offset from the end of the pipe. So we need to get the projection of the pipe first. So let's save this and come back to the pipe itself, and I get the projection from here. Copy and come there and paste the projection. And now you can add the offset. So the offset, if we measure it from here to there, it's 15. So the offset is 15. And now if you would like to add some other ribs, like adding another rib on the other side, you can do the same thing, 23, and that's the width. If you would like to add another rib on the other side, the same for that. So we can save that, and you can run the assembly to add stiffening grips for this nozzle. Okay. Okay, I will make a modification on the second rib to make it this rib. Okay, and click on save and make the offset equals the offset here. So it will be 15, 15, 15, and click on save. Now let's run the assembly to modify the ribs offset. Okay, now we have those ribs. One more thing I would modify it, make it on the make it on the other side. And click run to add another rib on the other side, like that. Okay, now by that way you can add stiffening grips for the nozzle and control the number of ribs that you would like to add. Okay, now let's add a nameplate. So if we take a look to this one, the nameplate located on the first can, okay, and the location from the seam line here. So from this point to the center line of the nameplate, it's 1050. So let's select can 1. From here select elements and let's add a nameplate. So from external, let's add a nameplate. Okay, and select the suitable type for your case. We could select this type and define that value, keep it as it is, and from here that's the thickness, and the projection we could make it like that, and here's the location and the orientation 170. The thickness of this one, let's add a okay, and from here let's make the offset from all sides, and here the height will be 180, and now let's click on save and run the assembly.